Okay, we're live.
Okay. Should I start?
Yep. I'm gonna put you on screen.
Okay. Can you see my screen on the right-hand side? I can't see my screen here. You can
We
all
can see your
it, right?
screen.
Yeah, good. All right, everybody. Well, thank you for joining this short information session and Q&A session about our Subsurface Energy Systems MSc program. I'm Ushton Nicholson, and so I'm an associate professor of geoscience here at Heriot-Watt University. And on the call with me as well, you should be able to see in the window on your left-hand side, Florian Doster, Hannah Menke, Andreas Busch, and Alexis Cartwright-Taylor. Do you want to give a brief introduction, guys?
Yeah.
Starting with Florian.
Yeah, I'm a professor here for multi-scale multi-physics modeling, and I'll be teaching fluid mechanics in this program.
Thanks, Florian.
Over to Andreas.
Hi, morning everyone, or wherever you are. I'm Andreas Busch. I'm Professor of Earth Sciences. I'm teaching transitional gas, and I'm contributing to the teaching of subsurface gas storage for this course.
So hi everyone, I'm Hannah Menke. I'm an assistant professor, and I contribute to the geothermal energy module of this course. Alexis?
Hi everyone, I'm Alexis, and I am assistant professor in geomechanics, and I teach the geomechanics part of this course.
Great, thank you everyone. I should have introduced myself also as the program director for Subsurface Energy Systems. I've been taken over this year from Florian, and I also teach the geothermal course as part of this program. So I'm just going to take you through a quick introduction to the SES program, but first I wanted just to introduce our institute, and then also the reason that we're running this program at IGE and Lyle and within Heriot-Watt University. So IGE is the Institute of Geoenergy Engineering, in which myself, Hannah, and Florian are based. And so we are the third ranked institute in the UK and the 12th in the world for subsurface engineering. And really our kind of unique selling point is that we really work, the engineers and the geoscientists in IGE really work very closely together to have this kind of integrated approach to research and teaching. So that's what's unique about our institute. And we also work very closely with one of the global research institutes here, which is the Lyle Center, in which Andreas and Alexis are based. And they both are part of the geoenergy group there. So this is a little bit of background as to why we're running this program. So I think everybody's aware of the situation with climate change and the need to change our energy systems fairly rapidly. But there's also an energy transition that's already taking place. And those graphs on the right-hand side kind of demonstrate that. The image on the bottom right is global investments in oil and gas between 2010 and 2021. You can see that investments were rising gradually up to about 2014 and then have started to decrease in the years since then. By contrast, the expenditure on projects related to the energy transition, so both in terms of supply and demand, have increased rapidly over the last 10 or 15 years or so, and you see it really an exponential growth in these industries, in these sectors. So there's a need for investment in this, and with investments come jobs. And the image on the right here is just a recent news article from the BBC that shows this announcement that there's a £22 billion investment from the UK government for carbon capture that is meant to as seed money for industry then to participate and invest additional funds in these large CCS projects. And we see similar things, similar growth in geothermal and natural hydrogen or hydrogen storage and other sectors. So in terms of delivering this energy transition, the subsurface plays a really key role. So both in terms of things like geological storage of waste products like carbon dioxide, of energy such as hydrogen, of waste such as radioactive waste, but also in terms of producing new forms of energy that are of low carbon intensity. So geothermal energy from the earth, and natural hydrogen as well. So the kind of focus that we have here in subsurface energy systems is in those outlined in green here. So we're looking at hydrogen storage, geothermal energy, and carbon capture and storage. And this has really been a key shift in Heriot-Watt University, and particularly in the Institute of Geoenergy Engineering over the last couple of decades, really, but particularly accelerating in the last 4 or 5 years since we started this program. So there's been a major pivot in terms of our research in particular, and more recently in terms of teaching towards the energy transition, and still working closely with partners from industry and other academics. And again, our emphasis here is on geological CO2 storage, where we take CO2 from industrial waste, or indeed from like co-produced CO2 from natural gas or oil, and re-injecting that into the subsurface, into deep into the subsurface, where it's retained over long periods, over many thousands of years. We also are researching increasingly in hydrogen storage. So that can be natural hydrogen, or it can be green hydrogen or blue hydrogen that we take and we store in the subsurface. And there's also a significant focus on geothermal energy, and that can be deep geothermal, as shown here, producing hot fluids from these granites for power, or it can be shallower geothermal from aquifers for heating and or for power. So the new Subsurface Energy Systems MSc program is really focused on this kind of geoenergy part of the industry. So transitioning away from producing oil and gas, and looking at renewable forms of energy or sustainable forms of energy. So this program was rolled out in 2020, and it takes the best engineering and geoscience expertise that we have in IGE and in Lyle and applies it to that energy transition. There are 8 taught courses across the first 2 semesters, which I'll introduce you to shortly. We have field courses both in Spain and the UK, a number of individual day courses in the UK, and a new course that's just been rolled out. And a team project with real data focused on carbon capture and storage, and then an individual research project, which will be your thesis at the end of the MSc program. So the taught courses are I'm just giving you a brief snapshot of what these taught courses are here. The first of these is in reservoir characterization. So that's understanding the geology of the reservoirs into which we're either injecting fluids for long-term storage or extracting fluids for heat or for producing hydrogen, etc. The second course is on gas storage. This is where we take CO2 produced by various processes, and injecting that into the subsurface, into subsurface reservoirs or aquifers. There's a transitional gas course, which is led by Andreas Busch on the call here, where we look at gas as a kind of intermediate fossil fuel, which is cleaner burning and produces less CO2 and can be coupled with CCS to capture the emissions. We have a course on geothermal energy that I teach, which looks at harnessing the heat energy within the earth and utilizing that as a renewable form of energy. We have a course on fluid mechanics, reactive transport, and heat flow, which is led by Florian Doster. So this image here shows a little model of a CCS, a CO2 plume migrating in the subsurface over a period of 1,000 years. We have a geomechanics course taught by our colleague Alexis and Nathaniel. So this is an image taken from the field excursion to Yorkshire, which has been run for the first time this year. We have a course on reservoir geophysics and monitoring. So this is where we use geophysical data to understand what's happening in the subsurface as we either produce or extract these fluids. This image here is a time-lapse survey over a period of 10 years, showing the migration of a carbon dioxide plume in the subsurface over that decade. And we have a course on environmental risk policy and economics taught by our colleague Aaron Cahill, looking at understanding the wider landscape policies of how you make money, injecting CO2, for example, which has no intrinsic value, and environmental risks associated with these different energy uses. After these 8 taught courses, there is a group project. So this is just an image of one of the group projects from recent years, where the class is separated into individual teams, and each team is given a project to manage. And in this case, it's a carbon storage project in the North Sea, where you have to understand the geology, predict fluid flow through time, understand the economics of the project, and so on, and then present that back to a panel of industry experts. And then there's an individual project at the end. This image here shows one of our MSc students from last year in the field with Nathaniel and Amy, they're 2 of our colleagues, looking at these potential reservoirs or aquifers for producing geothermal energy on the campus. And this image here is just my personal favorite part of the MSc program, which is our field trip, our annual field trip to the north of Spain, where we can see the geology exposed at seismic scale. So we can see here one large anticline in the background as a kind of analog for long-term carbon capture and storage. And then just to recap what the program is about, it's a 1-year MSc, so it's quite intense. Full 12-month MSc program focused on integrating geoscience and engineering, engineering of the subsurface for the energy transition. We have 8 taught courses, which include both fundamental, the kind of foundations, the fundamental geoscience and engineering that you need to know, and then applying those to different energy solutions. We have 2 integrated projects looking at real-world application individually and as a group. And finally, the applications are open for 2025. So the next intake for students is in September 2025. So thank you for listening, and I'm happy to open the floor for any questions that there might be.
Just a clarification, Ustin. When is the deadline for applications? You say applications are open. Is there a hard deadline for admission?
I think the hard deadline is, I don't think there's a fixed hard deadline. I mean, probably with a few weeks before the semester starts, but that depends on whether students need visas, for example. Mm-hmm. Obviously, if they need visas to get into the UK, then they should apply as early as possible, really. Mm-hmm. And just one other point here, that there is I decided not to show the video on this kind of webinar and Q&A session, but if you go to our website, there is a video and some more information on the course structure, the program structure, and so on. So please do take a look at that. Okay.
Oh, so 2 people have just joined.
Okay.
And they get this at a delay. So if they have any questions, we'll wait a couple of minutes.
Okay. Yep. So for those that have just joined the call, we've just run through a presentation just outlining what this MSc program is about. This has been recorded, and we think, Hannah, I think it'll be available in some form after his.
Mhm.
But in the meantime, since you've joined, if you have any additional questions, please feel free to ask. And indeed, if there are any points of clarification from the others on the call, then feel free to make them.
Øystein, let's quickly discuss something really important, and that is job opportunities for people that are finishing this course. I mean, it's probably, besides the content of the course, that's usually what students are most interested in. And maybe you can give a bit of an overview of where our previous participants of this MSc course have ended up with. So, which is quite interesting. And we're also very proud of this because a lot of the people, or actually most of the people, are now really working in the energy transition. Let that be geothermal, rather at smaller companies, of course, because the very big companies, so the Shells and Chevrons and BPs of this world, they are not so much into geothermal. It's more like a business for smaller companies, for SMEs, basically. But a lot of the people are working in such companies, and that demand is growing a lot. And you can see that, I mean, it's not because I'm saying that, you can really see that in the number of jobs that are advertised in geothermal energy, not only in the UK, but all across Europe and many other parts of the world. The second one is CCS. CCS is a topic for the bigger companies. And if you look at the landscape of CCS projects in the world, let that be in Europe, specifically in the North Sea, Southeast Asia, Australia, continental Northern America, there is a lot happening, and there is a huge demand for experts in CCS, both in geoscience but also in subsurface engineering. So watch that space. You will also see that there's a lot of projects under development. This is where you actually need the people, not when the projects are operational, right? So then you need operational managers, but you know, to come in with specific geoscience and engineering expertise. This is really in the FEED study, so on the front end engineering and design, which takes a couple of years, and we will see a lot happening in this area. A bit similar to hydrogen. Hydrogen is more emerging topic, so subsurface hydrogen storage, where there will be a growing market in the future. So it's good to get prepared to it. And of course, we also recognize in our course that there's similarities between subsurface hydrogen and CO2 storage. But then also with regulators, policy development, geological surveys, of course, environmental agencies, NGOs. It is, and Øystein has shown you the numbers. I mean, it's only the UK that is willing to invest about 22 billion pounds. That's 25 billion euros, or about probably like $30 billion in the next couple of years. And I mean, if you extrapolate that to the rest of the world, that gives you an idea what the investment is going to be in CCS. So this is enormous, and it is supposed to change also a lot of jobs from oil and gas into CCS. So there's a huge opportunity there, and we see a lot of people that are getting a job in these companies. And of course, finally, we also, of course, have a lot of MSc students that then continue with a PhD, so they rather stay academic. So I have one in my group. I know several others that are all around the world doing a PhD now because they're just interested in the science of it. So there's growing and a lot of opportunities there. And of course, our MSc is getting you prepared for it.
Yeah, no, that's great. Thank you, Andreas, for that. I think that's a really good overview of what the landscape is in terms of the opportunities coming out of this, and it's really an exciting time to be involved in geoenergy. You know, the both in terms of research, but also acquiring the skills at MSc level to work in this sector. So yeah, that's well highlighted there.
And we have a question in the chat from Pankaj. Hopefully I'm pronouncing that right. So what's the selection criteria? He says he currently has a B.Tech in petroleum and finishing an M.Tech in petroleum in 2025. So what kind of selection criteria is the university looking for?
So we are happy to take people with both an engineering and a geoscience background. And in fact, there are some people also coming with a physics background, for example. And the engineering, you know, we have people who are chemical engineers, we have people who are petroleum engineers. So yeah, absolutely no problem to come for the petroleum engineering background. It's a broad program, so if you're coming with an engineering background, the geoscience will be more of a steep learning curve, and if you're coming as a geoscientist, then the engineering will be the steeper learning curve. But yeah, I don't see your Pankaj, if I'm pronouncing your name correctly. I think your that background is very well suited to SES. We have, in fact, this year we have, I think 40% of the students in the class or so are coming with a petroleum engineering background. Good, thanks for that question. Any other questions from anyone?
So, maybe also good idea, and maybe one of you can respond to that question. So how does a group project look like? What do you do in a group project?
So in the group project, the students are given it's a real world data set that's anonymized, but they're given some subsurface data, some geological data. So they're given some well data and some seismic reflection data that they have to interpret to understand the physical nature of the subsurface, of the storage space into which they're injecting CO2. And also some information on the cap rocks, including some experimental results to show what the geomechanical properties of the cap rocks are. And then they have to run some simulations. So once they understand what the reservoir properties are like, they have to run some simulations for CO2 injection, on looking at different scenarios for how they would inject CO2 and to come up with a kind of optimized strategy for CO2 injection. So much like in this figure here, you can see here that there's a well injecting CO2 into the aquifer. That plume migrates through time, but if it intersects faults, is it going to migrate up those faults? Is it going to be trapped by those faults? Those are the kind of questions the students will have to answer. And then they also have to look at, they have to do an environmental assessment, and they have to look at the economics of the project. So thinking about how to optimize the storage at the best possible or the lowest possible cost, and then they have to present those results to a panel, a group of industry experts who review their work, and of course that their thesis is also reviewed by the academics here as well.
So I just joined in here because, Oystein, you formulated a lot. The students have to, but it's actually quite exciting. You're developing a field like in 2 months. You essentially mimic the whole development process that would happen in real life. Apart from you're not sending out the drill rigs to drill wells, or this has been done for you, but you're really starting from scratch and you're exploring in a team. Is that a feasible storage site? What would be the capacity of it? And follow a typical workflow that is followed in the industry, and draw from all the lectures that you've had during the taught courses, so it's much less have to than more like yeah, students really enjoy that, and the feedback is overwhelmingly positive, that like kind of it really brings together all the pieces. And yeah, so I want to add on that.
That's a good emphasis. I mean, I use have to as in you're so motivated and overwhelmed with desire that you just simply can't stop yourself. So no, that's great. There's another question there from Pankaj again about scholarship opportunities. So, are there any scholarship opportunities for international students? There aren't at the moment scholarships for the program, but we are currently looking into, or we're in having some discussions, preliminary discussions with some of the alumni and some companies about possible scholarships. So it is something to keep an eye out for on the website. So those discussions will be ongoing for the next couple of months, I would imagine.
I just want to hop on something. You mentioned that the group projects are reviewed by industry experts. So could you maybe expand a bit on whether the program includes opportunities to network with industry professionals? Are there guest lectures or industry talks?
Yeah, there are guest lectures on a number of different courses, and also some lectures associated with the group project. So, for example, my geothermal course, we have a guest lecturer coming in to talk about mine water geothermal, which is picked up a lot in recent years here. On the gas storage course, there's Owen Tucker from Shell that comes in and gives a series of lectures. I think it's a couple of days. Andreas, do you know, or Florian, how many days Owen Tucker comes to teach?
I think in total it's 3 days, 2 in gas storage and 1 in environmental risk and policy.
Okay, yeah.
That's right.
Yeah, there's a geomechanics. So Alexis, you want to say about geomechanics?
And I should add, so Owen Tucker really is like kind of the CCS lead of Shell. So
yeah,
we're quite pleased to have him in the lecturing team.
Yeah, in the geomechanics course, we have 2 days of guest lectures. We have Sean O'Neill from Shell and Mark Davidson, who I think is ex-Shell, and Mark talks about wellbore geomechanics and gives a lot of industry examples of when things could have been done differently and what the learnings were from all the different test protocols and things to understand stress changes in the subsurface. And then Sean talks about fluid pressure in the subsurface and problems with overpressure and how you manage that.
Yeah, great. So yeah, I think at least half the courses have some guest lecturer from industry with relevant expertise on those topics, and then there's some also for involvement with a group project in particular. And then the individual projects, they vary. Sometimes they're done in-house here, but there's also quite a number of students who go out to work with or who work with industry or industry data sets with an industry partner on projects. So we're very open to that. And sometimes those are industry partners that they are, that they might be sponsored by a company from their home country. So last year, for example, we had a student from PDO in Oman, and they're interested in carbon storage in a certain context in Oman, for example. Or we have students coming from different places, often often who are being seconded out for a year from companies and who want to do a project on those data sets. So yeah, and we have very good connections with industry here, for both the research and teaching. So there's lots of opportunity to look into very applied projects with an industry partner. Good. Any other questions? If not, then I guess that we leave it here for today, but do feel free to get in touch. I should put my, I don't know, we can put my email address or something in the chat. I didn't put it on the slides, so is it on the chat is just with the moderators, Hannah? Is there a way to put that? Can I put that in the Q&A?
You can put that in the Q&A. Yeah.
Start a discussion. Okay, my email address is here. So yeah, if anybody wants to get in touch and has any more questions, please feel free to email and ask. But in the meantime, thank you for joining, and thanks also to the others hosting the call and for your contributions. And we hope to see some of you in September 2025. Thank you, everyone.